All right, let's see here if everything works as it should. I'm gonna waiting for the live feed to come through my own. Yes, it seems to be working just fine. Let's see here. Yeah, that's nice. That's good enough. Good enough. That's good. It works. Where were we last time? Let's see here. I'm gonna adjust my camera a little bit. That should be nice. So we had just been making this third-person camera controller, or our character controller, with a very basic third-person controller, camera controller. So the camera is just fixed behind and follows. I mean, this is very rudimental, but we were going into the overview situation where we could go left and right, and let's see here. I think we were having some problems with the left and right, so let's dive into the code and see what I can get going. So the wrong project, let's see here. So we had an issue with the divide by 0 and other stuff, where I didn't put in the right value. Now we have the right value coming through right here, and then we use that values of the we have. Okay, so let's start from the top here. This is our play controller. We capture input, normal Unity input. We just set the rotation of the character to 0 because we rotate the character in other ways than its root entity, and we go through and we update. But if they are in third-person mode, we move them XYZ or XZ mostly based on input and mouse delta. So we rotate player and we move the player based on input, and then we have the camera set that makes the camera follow in third person. And then if we switch over to overview mode here, if the character has an overview mode component on it, it goes into this RTS style camera movement. And we had some problems with this by moving left and right when you push your mouse cursor all the way to the left or all the way to the right. Yeah, we should just start by fixing that. And I've thought about it a bit the past days, and I think I got where I might have done wrong here. So we have our X position that we move left and right, and by dividing our mouse position by the width of our screen, we get the normalized value, 0 to 1, and then we have a frame value which is in normalized space, so to speak. So our frame for when the mouse should be detected as coming close to the edge. So it's imagine like a picture frame. If you go into the picture frame area, you will make the whole camera move like a normal RTS game. So this value is 0.05, so that means 5% of the screen is the frame. And when we go to the left, when we want to go to the left, we want to make sure that our X value is below this value. That means we are in the first 5% on the screen, and then we want to translate that almost at the edge of the frame to all the way to the edge of the screen. That little span of values right there, we want to translate that to more or less movement in that direction for the camera. So the more you push your cursor out to the left, the more you move to the left. The first thing we should do is not turn this value upside down, I think, because we need to still just divide this, because then when this will just make it 1 when we are all the way to the left, and 0 when we are close to the edge, close to the frame. And we should just first of all math clamp this. Clamp. So we get a situation where we only can have 0 to 1. That's very important in this case. And we can probably just try moving to the left right now and see so that works. Should be just fine, I think. So if we press over here and we start coming close, and then we hit the edge and it starts going slow, and oh, so it's reversed, right? So we have going all right here, really slow, but still it's moving, and then 0 here. So we need to flip that span, and that should be by doing by not actually having a minus sign there. That's about it, actually. Oh no, my bad. That's not correct. Let me rephrase that. I'm gonna explain. I'm just waiting for my computer to not start, and now I accidentally pressed it again. So what happens here is more that this value should be negative, because we want to RTS move the camera in negatives on to the left in X negative, right? But this value should be flipped. And I think we can do that by doing just 1 minus the value, because then we flip it from being from 0 to 1 to 1 to 0. And that should actually be enough. Overlays is... Jesus Christ. Yes, thank you, Daniel, my old friend. Holy shit. That was interesting, very interesting. Me being enormously not used to streaming, but I'm trying. So let's recap here. So what we had before was that so let's see here. Well, what we have had before was that when we start moving, when we got close to this 5% edge here, right, the value got turned all the way up to the top, and we moved fast right away. So but now we flipped it by doing the 1 minus the value in question, and then that makes it so when we go here we have 0, we have really slow speed, and then when we move more out we get faster and faster. Now the speed is really slow, so we should just increase that to begin with. So we have RTS camera speed 10 right now. I think that should be like 100 times, 10 times higher. So there we go. Really slow, really fast. That's a normal RTS camera. So now we should do the same with the other, going to the right instead. So now we have this, we turn around this value because we want to find when the x value is above 0.95, so the last 5%, right? Let's see here. Yeah. So we want to find those last 5%, right? And we do that by taking 1 minus 5%. So we get the 0.95 left. And then I think we should turn this value around once more, the value itself here that we are comparing. So if we do like this, 1 minus, that means that this value, which because of this if statement is somewhere between 0.95 and 1, so the last 5% of that, we turn it around and turn it into 0 to 0.5, and that means we detect all the way to the edge. So now if we use that, Now we have very similar thing. It's just that it's also turned around here. So slow, fast. So if we turn that around once more, I know there's a lot of turning around here, but I think it will pan out just fine soon. So first of all, we can normalize this or clamp it. So 0, 1, and then let's do it like this. So the clamping won't do much difference in this case right now, but then we turn around that value. And that should be it actually. Yeah. So I think that's good enough. Let's add that to the y-axis and then let's move on to the next part. So if we just copy this basically and then swap out all of these to y, and then we make the camera move in y instead of x when the y is triggered. So this is the same thing, it's just for y, and we're probably gonna have to turn some values upside down because y is in a, might be upside down or the right way up, I don't know. So it doesn't work at all. That's interesting. Let's see here. Let's print this value to see where we're at. Unity engine, and like I said, this is something we can do straight into dots if we are not bursting the value, if we're not bursting the whole function. And we are not bursting right now, because, or this one, because we are trying to develop it, so the performance is not our main concern. All right, so let's see here. So we should get some stuff written out. Yes, that looks perfectly all right, and that value goes, yeah, it goes like it should go. So it goes from almost 0 to 1, right? And that should trigger a movement. So obviously there's something else that is going wrong. So this value has valid values. This variable has a valid value. Then we take this value and we push it through these systems, and we should get something out that is valid as well. Unfortunately, we do not. So let me check that. We should try this value that comes out of this system as well. So now I'm looking at the camera movement value, so basically camera velocity, which should give some indication, because that right now is 0, right? And we clear and we make it go all the way down, and it's, well, that also works. So that means that we are putting in the Y movement in RTS camera. It says RTS move is equals to -1, and we should be moving straight down right now, but for some reason we're not. And I just think I realized why, because it's not the Z, it's not the Y-axis we want to move in, it's the Z-axis. So that's an interesting issue by me, but when you turn around the camera, sometimes you get confused. So let's see if this works. Now we are just making the RTS move variable go in the Z direction instead, and that makes it. So I think we have an RTS camera working pretty well actually, or pretty well, I don't know. It's working at least, and there is us, the little guy on the ground there. So we should move on with the next step. So and there's a bunch of stuff that we can fix in this with all of these. I don't want to spend too much time on that, because I can clean that up when that's not really relevant to learning dots. But one thing I want to do is swap out this viewport size, because as it turns out, I don't need to pull out the camera pixel width and pixel height. The screen, so the screen contains all the relevant information. So if we do new Unity engine.screen, no, I mean float 2 obviously. I'm gonna get to Unity engine dot screen dot width and then height. So yeah, because we actually don't need to use this particular get function here to get it straight from the camera. That was just me thinking that the screen value was not valid, but it was. It turns out those 2 values are the exact same, and this means basically we don't need to keep track of this viewport size manually in the background. Yes, so let's see here. Any questions, just shoot them in the chat and I will answer everything as I go by. And this seems to work just fine, so we can take away a few lines of code with that and makes it a little bit easier. And the original problem we had is not really relevant anymore, because before we had a divide by 0 problem, because this value we swapped out right now, the value before was sometimes 0, and that made the whole burst thing just crash miserably. So let's just move those out of the way and take away that. So we have a situation where we want to do some very, very high performance selection to build a stage. I want to be able to have thousands of these guys on the ground. So this is just my commander, right? But we have a few of his buddies that is like Flamebot, a little bit smaller, but he has his own purpose. And I want to be able to have thousands of these guys because that's something new that I haven't seen in a lot of games. Like obviously there's a lot of RTS games that has thousands of characters, but it's rare for small teams to be able to pull that off because it's very performance heavy. So I want to try to make this very simple but very performant with the help of dots. So first of all, we should probably generate all the units on the ground so we have something to actually select from. I think that's the first thing. We should just build a simple spawner which just populates an area with a bunch of different objects so we can later try to select them. So let's remove this flamebot and let's create a script called debug spawner. And this has this is not just a spawner. This will be quite for those who are new to dots. This will be interesting because I will show off some few things that is very relevant if you want to try to program in dots. So it's not just a run-of-the-mill spawn system that you will do in traditional Unity. First of all, I always like to use a box collider to make it set the scene for where stuff should spawn. So it's easy to see and easy to manage, and then just have the box collider itself disabled from the start. So let's do something like this where we have let's see here, box require Unity isn't it require component. There's something I miss here. There's something that makes you able to like request for one component to always, or mono behavior to always be present. I think, oh, I'm in the, my Visual Studio is always opening the wrong project. Often because of this reload thing, it's blocking everything. But anyway, so I want to have the box collider from the start. Require component, there we go, type of, and let's say box collider right there, should be fine. So now we know we have a box, and we want to do this spawning on the start, right? And we want to base this on a prefab that we create. So we're going to create a very, very basic version of the unit that we want to use, right? And I think we want to do it we should try first to do it the first frame, the first conversion frame. But if our stuff, if all the collision is not set up properly, maybe we should like hook up in the first valid frame of the game and do the spawning then. Some stuff are a little bit tricky to bootstrap when you're converting the whole system in the start. So, but we'll get to that. first of all, we need a prefab we want to spawn. And we're going to use a normal game object here. Object to spawn. Could be spawn. Good name for that. But what we want to do is we want to convert this. So we have something, first of all, we want to convert this whole thing. So let me think here for a few seconds. We want to use DOTS code to spawn all of these guys, because they're it's very performant to spawn like 10,000 objects if you're not using something like DOTS. So we have something called unity.entities.iConvert, and I will get into this. I think I used this in the other, so some of you have already seen this if you have looked at my other stuff. But this basically have our convert function, and we can probably do the spawning and everything in the convert of this. We'll see where it ends up. But the point is, I want to be able to make this game object a prefab in ECS or DOTS style, in that type of framework. So when we spawn that ECS entity, it goes much faster than instantiating the game object that we are basing it on. I'm gonna dig up a little bit of a code from another project because it's hard to remember this stuff. Let's see here. I know I have like this in entity prefab collection. I have this code like all over the place, but I always forget how to use it, because you can see it's quite a few lines of code, and I'm gonna have to convert a few, and I'm gonna explain to what's going on here as soon as I'm done with this, with just making it work. So let's see here. We want to find a similar thing. There we go. So halfway there. Var prefab, and then we will have our object to spawn here. Oh, hi Messietti. BRB. He's coming back. I've seen all of a few names, and I read them like 10 times, and I still have a trouble pronouncing it when I see them. I'm sorry for that. So right now we have a conversion settings object, and that means basically Unity has a lot of conversions tool built for you that helps you convert traditional Unity objects to DOTS based objects, and this conversion settings is one of them that you need to use quite a bit. In a convert function, there's an easy way to do this, and it's basically, I don't know the specifics of what is happening behind the scenes right here. What I know is that this object contains a bunch of settings that sort of like instruct the conversion system of how things are set up right now. You can create this yourself and create your own conversion flow and stuff like that. But this way you can use this game object conversion utility, and that basically takes a normal Unity object and converts it into DOTS, or at least it takes all of the parts it can convert and makes it into DOTS. And that includes mono behaviors where you have made this convert override. So by calling this, by converting this object to spawn to an entity, you will call your convert functions also that is assigned to that object if you have any mono behaviors with this convert on. So when we have this, we can easily start to do the normal stuff. So we can add a count, and we can take the box, var box, and we still in normal Unity right now, so we can do box collider, and we will get straight into we will get our box, and then we should first of all we should create an array for all the resulting entities we want to create, because one of the things that Unity have a lot of ways to help you with is a lot of stuff that you can do with with DOTS, with the ECS, the entity component system. You can do that either one by one, or you can like send in some sort of a thing that tells Unity to do the same thing a bunch of times. So for example, spawn thousands of stuff at the same time, and they will then do that stuff behind in their backend super fast. So you should always use the version of you should always try to spawn everything in batches if you have a lot of spawns to do. So in this case, we're going to create a native array, and I'm going to entities. I'm going to explain that more soon. New unity.collections.native array, and then entity and count, and like that. And I'm going to go through all of these points straight away, and it's going to be a lot easier to see what's going on. So native array is Unity's own collection system that basically is backed up by Unity's own memory management, or so that's what I've heard, sort of read. The specifics is not really relevant in a lot of cases, but from what I understand, this is their own memory managed collection system, and with an array, you just specify how many you want to and which type of array. So, and if we look at what's available here, we have, there are really only two that you need to care about here. It's persistent and temp job. So temp job is the one you use all the time to be able to do anything. Temp you use inside of a job, and we haven't gotten to that point yet where we used a job yet, so it doesn't really matter. And persistent is basically telling Unity, yeah, this will probably live like for the whole game session or something like that. This temp job for me right now, that's just because I want to create a temporary array for Unity to fill in with my entities. So now we have an empty array of a lot of entities. And if we then do like this, dest manager, so this is our entity manager, and we do instantiate, so that's similar to what you used in Unity, but this takes different stuff. We can see it has a bunch of overloaded methods, and one of them has a source entity and then an output entities that is an array, and that's what we're going to use. So if we put in our prefab as a source entity, and then we put in entities array as the output array, that means that if this count is 1,000, it will create an entity array with an array with entities of 1,000 entities, and then this line will fill them each with an instance of this prefab that we just got from the conversion. So now we have all our stuff. Now we need to place them. So let's do a for loop for that. So we have count that we can use, or we can just use entities length, and I think it's more cleaner to use entity length because it's after all the entities we are looping over. And then we should create a few a few raycasts. First of all, random positions in X and Z, and then raycast and find a spot and then place our unit there. So we can do something like, we need to do the same thing that we did in the player controller. We need to pick out the physics build world, so we can get our physics world and then raycast against that. So let's start with that, but it's going to be a little bit different here because we're in a convert function. And this is one of those things that I am not sure if this is going to work in convert. If it doesn't, we'll just move the code over to the first update loop. It's not a big deal. It's the same code either way. So let's do something like this. Build physics world, or we can just name it physics world. No, you're gonna understand why. And then we're gonna start using Unity physics systems. And instead of using this world, we're gonna use this world. So every entity manager has a world associated with it. That's basically all the data associated with it's like a chunk of data that represent an entity-based world. and you can have lots of them at the same time. I haven't found a reason to right now, but this way we get the build physics world from our world that we are right now converting into. So, and let's create a random object so we can do some random positioning. Random, new random, and we're gonna use this stuff right here from Unity Mathematics. So this, another random, let's see here, and we actually gonna have to manually put in our Unity engine namespace again. Oh no, we can skip that. We can do like this instead. We can specify our random more precisely like that. And that this takes a uint seed. I have actually a function for that in my other project, so I can just move that over. MISC utilities, and then we have a random. Let's see here. Create from random seed, and this one is the one we want to use. So it's a little bit tricky to maybe do this if you haven't never seen it before, but you basically need to generate a random value that you can use to seed the random, because if you don't know, every random needs a seed somehow. Unity's own random that you used to just have a built-in way to do that. And one can argue that would be easier, but the new random is faster, so I think we should use that. This comes from system, right? I just wanted to know which system.random, right? And we can actually do it like this instead. Variable, and then we name it random like that. And then we have a bit converter. We can fully qualify that instead, system like that. Variable seed. So let's go through what's happening here. We can name that fast random so we can tell them apart. So we make a normal system random, and that's because we just need a good start seed, and then we generate a few bytes. We just fill this array with a few bytes and then convert that to u integer 32, and that is the thing that Unity's new random wants as a seed. And the reason why I do this is it's a little bit overcomplicated maybe, but this is a good way to get a good fast random generator going. You could probably sort of replace this with whatever random solution you usually use, but now you can see sort of how you can set up the mathematics random in Unity DOTS. And yeah, that's one of the things that I have started to do in DOTS, using their random, because it's really fast. So let's start by doing a x value, and now you can just do the float, next float like this, and it works like you would expect. However, I want to make it random inside of the box that we want to spawn in, so our x and z values get inside of the box, so everything gets randomly spawned inside of the box. So we can actually move this underneath here, and then we can do min position box, and I think we can actually do something like this. Let me once again grass spawner pull over this, and you will see it clearly what I mean. Box. So first of all, we need to find the position we're at right now, and then the box might be offset from you know, like the center offset that you have in your normal box collider in Unity. And then we need to make one, the minimum is the size minus, and the maximum is the size plus, so you get a range between them. So this means we can do min x and then max x like this, and this will randomize between the min and the max value that the box contains. And we do one for z as well. Unity Med doesn't pick a random seed automatically. Yeah, Cadfoot. Yeah, that's correct. It doesn't. Well, it does and it doesn't. It's no, it doesn't. That's the thing. And the reason why is because it's very. You can put a Unity mathematics random inside of a component, so it's like it's very much a self-contained randomizer. So there might be a utility function from Unity that seeds it for you that I missed, but this is like 3 lines of code that does it for you. But random from system or random from Unity engine, those are like statically defined, statically constructed randoms that is based off something at startup. And then that's it. It's a global randomizer. Random in Unity mathematics it's a different thing. It's more like a isolated small struct that has its own internal workings and that doesn't depend on anything else. So in a Unity DOTS project, you often generate a bunch of different random objects for different parts of your game, and it sort of works in isolation for itself. And it can work on its own thread, for example. It doesn't need anything else. So while I do agree it should just be randomly seeded in some way, it's a little bit different the way they think about it. So it's different, and some things are certainly for a reason, although I can't really explain them very well because I'm not that read up on them. So let's raycast. I'm just jumping straight into the next thing here. But anyway, we should get our collision world. The collision world we will use to world like that. Physics world dot collision world, right? So we're gonna raycast straight down in the ground and find all the spawn points. And this is the stuff that I don't really know if that's generated properly in the convert function. So we might have to move this out, but like I said, we'll get to that. Let's do like this. We can also pick a height point, so where we're gonna spawn raycast from, right? Float height like that, if I can spell correctly, and then we use a variable start pos. New float 3, and let's put in x height z inside of that. Makes sense, right? So and then float 3, not 4, and like that. And then we have the end position. So this should be like on the bottom, and our world should be right in the middle, and it will find a spot in between somewhere. Makes sense. And if we don't find anything, I don't really know what to do. So we should probably. You can also make an alias by putting. Yeah, I know. Clash like that, great tune, but really enjoyed the last one. Thank you, Catfoot. Thank you for the input. Yeah, that's right. You can statically define a bunch of stuff right up here so you don't need to. Oh, you mean the whole thing? Yeah. Is that not required though? Using random. That's a fair point actually. Well, yeah. It's just it breaks off your stuff in 2 different lines, so I didn't see if you were meaning a statically renaming of a namespace like that. But I think that's what you're doing, and that's a good, very good point. But anyway, I think since this is going to be open source and I want people to understand what's going on, I think it's a good idea to do this type of thing where we do it like that, because it's very obvious what we're using, and since this is supposed to be new for people, I not supposed to, but I would expect a lot of people who look at this who are new to DOTS, so then it will be very crystal clear what we're doing, and yeah, that's one of the reasons, and it just works, so why, I think it's enough there. Collision world, raycast, new input, and then we put in our start pause. Let's just name them start and end. It's easier that way. And end, and then we need our collider. So we should use the same thing we use for finding the ground with our RTS camera. So we should just copy this ground tag thingy, paste it here, and use this namespace to find this one. And then we can use the same, we don't need to do this over again, so we can just do the same thing here, and create the filtering tag, or the collision filter from this ground tag, and that is done by doing it like this. Collision filter, let me just finish up this. So yeah, that looks nice. So we create a new ground filter, belongs to, we just say belongs to everything because it's a raycast. It doesn't really care what it belongs to, it's just our explicit raycast. And then what it collides with, what the raycast will hit, is the ground tag value, right? Let me see here. Now we're getting into the namespace collision here. Let me think about it. Let's do it like this. So, okay, so we create our ground filter based off of our ground tag, which will be set in the inspector later. And one important note here is I put Unity Engine in here because Box Collider exists both in Unity Engine and Unity Physics. That's why in Player Controller I don't have Unity Engine here. I just have Unity Engine like everywhere. And for consistency, you know what? I'm gonna do the same here because it's gonna end up almost like that anyway. So let's do it like this, and it's not a lot of changes. Yeah, there was really not a lot actually. But anyway, let's back out. Now we have the ground filter, so we can find the ground and put our units where we want them to be. So we should put this into the filter that the raycast is asking for. And then we also need the out variable hit info. This is just the raycast hit if it hits anything. And if it doesn't hit anything, we got some issues because then our box is not above ground, so we try to put stuff where there's no ground, and that's not good. So maybe we just do something like this, else Unity Engine debug error no ground. We probably never will encounter this, but it's easy to put in. So we found our ground, and we want to put our character there, or our entity there. So and our entities are filled into this array, right? So we want to set a component now. Set component data, and right now we are on a specific entity, and we want to create a new translation data, or translation, like that, and we can make, yeah, that should be enough actually. And let me explain what's going on here in a few seconds. So what we're looking at here is that this is the position where we hit our array, and this is our entity that we're trying to place. And so to change the start translation, the local position, which in this case, since our entity does not have a parent, its local position is the same as its global position, right? So we just change the component translation on it, and that is done by just setting to a new one. That's how you change a component. You just set a new one. So it should be placed out at the right point right now. So we should just yeah, this is gray out. Let's keep it there because it's more explicit what random we use now. We should try this. There's a few more things to set up, and this might not work in this case. We'll see. We might need to put it out in the update loop. We should fill in the stuff in the spawner in the inspector and see what happens. And we have another few things to actually fix before. So spawner, debug spawner. So now we got our box collider, and we can just make that box collider super big. Wrong one. I'm not gonna care about the Y value. Is that too big maybe? Yeah, that's too big. Let's just have it 100 times 100. Like that. So it will spawn all around this guy. Like this. And like I said, the Y value doesn't really matter because we are going to be let's say 500 units up in the air and raycast 500 units down under the 0 point. And then the ground tag should be the ground. And then we have our object to spawn, and this is our object that we want to spawn. And right now we can just we can make a cube and make it a prefab and just spawn it. That should be pretty easy. So let's reset that. We create a prefab from it, and we might want to make it a little bit bigger actually, so we can see it easier. So maybe 4 times 4 times 4, something like that. And then let's make sure it's converted. We'll fix that. So we put in convert to entity, and that adds this convert to entity object to it. So it gets converted when we press play, basically, or when it's or when it comes to this line here, where we explicitly ask for the converted version. So let's see here, spawner, and let's put in cube. Probably gonna have a few errors right now, but we'll fix that. No, we did not. That's because we didn't put in any count. So let's spawn 10. See what happens. Oh, one more thing. This spawner is converted, and the actual spawning of all the stuff is done just at the convert stage. So we need to convert this spawner to entity values, the entity system as well. Now we're probably gonna get some errors. If it wants to, I think it's, yeah, no ground. Oh shit, it didn't find any ground. That's interesting. So maybe that's just because we haven't gotten the ground generated yet because we're in convert. So let's move this to do it in the first update of the game instead. So let's create a system class, spawn system, and system base, and let's make an update, and let's make a value that makes it only run a specific thing once. We can actually make it. I have a better idea. So let's make a struct a spawn data I component. So we can create this iComponent and then an entity with that, and make that spawn all our stuff at the first frame and then destroy itself so it doesn't spawn again. Another good exercise in looking at how you can do this type of stuff. So I'm just going to let the sort of the errors fill in what I'm missing. So I'm just going to start with the entities for each loop, which will loop through all of these. In data like this, and run it. And if we now take all of this stuff that we have in here and push it there, we get a bunch of errors, right? So let's see if we can make these things happen over here instead. So let's see here. Let's move out these stuff first here. So the native array like this. So the first thing we should probably continue with here is count, right? So we have the count of how many we want to spawn. And then we should have the prefab. So the prefab is just an entity like that. Data dot prefab makes sense because it's that object we're pulling in here. And then we should have a random, and that random we can build that and use it straight on the fly here. That's easy. This way we don't really need to move much stuff, and makes it easier for everybody. Fast random like that, and then we have a minimax, and the minimax is both float 3. I'm just gonna check the chat for a few seconds. DOTS is kind of niche on YouTube, at least. I haven't seen any practical use, only basic tutorial to monetize. And I like I wrote in the post about this the first time. I'm not looking to make money on this. If one day I could, that would be super fun. But I mean, I'm trying to start up something where I can actually teach some people how DOTS can be used, or not teach. Yeah, I'm teaching obviously, but it's not like I see myself as somebody who knows all of this stuff perfectly well. I wanna get better myself and try this out and see if anybody appreciates it. And so far, I think it's going great. And I really appreciate people checking in and see if they can learn anything, or see if they can learn me anything. That's that's just awesome if that would happen. Height data. I'm sorry that I'm slow at answering stuff in the chat sometimes, but it's mostly because I need to be focused to make progress. So I will try to keep a track on it. Public. So I'm just moving everything over that I want to move, and by doing this we can actually create one of these spawn data in the future or somewhere else in the code and make stuff spawn after we started. So this is actually a kind of good thing to do. Ground, and then we have the collision world, so that should be completely moved over here. Like this, and I'm just gonna name it stuff. You're gonna see why I do it like this. I'm just trying to make it as fast as possible, not as fast as possible, but quite fast. And like that, and everything should fall into place. Yes. So our spawn system will always be on, and it will find our spawn data, which we'll create soon, and then it will do the same thing that we designed, exactly the same code. The difference is that right now that we're going to make a command buffer which will do the instantiation, because then we burst it by having entity manager, which is, you know, this was this code, right? And this entity manager named DST manager right here is the same thing as the entity manager is in the bottom of system base. So, but we don't want to use entity manager inside of run because that's a little bit slow and unnecessary. So we want to make a command buffer equals the new entity command buffer. And for those who haven't seen this before, I brought this up the last stream. This is basically a record, a buffer for recording actions and modifications to something, to our entity manager, to our entity database. Our entity manager is normally our like sort of way into our entity database, but we can also like make this stuff happen. Oh, no overload method takes 2 arguments. Yeah, that's right. Now we're getting into interesting stuff here, because this command buffer can't actually use the instantiate version that takes in a whole array and fill that. I don't really know why they haven't done this, but what we can do instead is that we can make these objects and then let this system just fill in the blanks. Or we can actually do this, because this is going to happen so rarely, so it's fine. Let's do the with structural changes like that, and then do like this. So I'm going to explain to what just went through my mind. So command buffer is the way we can make this code run super fast and still be able to modify our database, because we're delaying the stuff. We're recording everything to buffer, and then after we're done with everything, we replay the buffer of all the modification, like, yeah, let's do this. But this thing where we spawn a bunch of stuff is gonna happen quite rarely, and we want to be able to use this instantiate which takes this native array, because we want to be able to let Unity create all our thousands of units in one go. And that version of instantiates with which creates so many, that is only accessible through the entity manager. And then we should just actually delete this spawn data, so it only spawns once, right? Because otherwise this update will just keep on spawning the same set of entities every frame, and that's a little bit unnecessary. So we can do this with a new feature here, and this is an interesting thing, which I don't think I've introduced. This is an entity query, and for those who doesn't know really what the word query means in this sentence, especially for me originally when I started learning this stuff from different stuff named queries in database stuff like 10 years ago, 15 years ago, I had no clue what query meant, and I still don't really know exactly what the word itself have exact definition. But in this case, entity query means basically we set up a bunch of rules on how we want to select entities. So we will set the rule that select all entities which contains a spawn data. So let's make an entity query, and let's name that query, just query, because the thing is that we are inside spawn system. The query we're gonna use is probably gonna be a query for the spawn data, because we're inside the spawn system. And now we can do this, and I'm gonna explain this because I didn't know this until like a few months ago, so this was new to me as well. So you can do this entity manager dot create entity query like that. This does the same thing. It creates a query for you. But get query in the system base is basically a way that Unity made for us, so we can like share all our queries across the code base, because you don't need 10 different queries that does the exact same thing. So this basically just, if it already exists a query that is exactly the same that you're trying to make, then they will just give you back that one. If it doesn't exist, it will create that one and put it in a cache or a library sort of, and the next time you may be trying to create the same type of query, it will just give you the same back that you created before. So that way you don't need to create new ones, and you can, this sort of automatically caching. So after we're done with our spawn data, we can call entity manager.destroy entity, and we can give that the query. So this means that we will destroy all of the different entities which own a spawn data, because the query gets all spawn data owners, and this destroys all those owners. That's it. And it's a very, very fast way of destroying and removing stuff. So this way you can basically clear out like thousands of entities by just having like, yeah, take away everybody that owns one of these components. And you can have, the queries can be very advanced and like encompasses a lot of different stuff. But that's for another, we'll take that when we get to that. So now we will clear out. So the only thing we have left now is that we want to create this spawn data from our start data. So we can comment out the original spawning, and let's just make the new entity which will own the spawn data. So we do that by creating a new entity, spawner entity, test manager, create entity. And this is it's almost weird, because this create entity does almost nothing. It just gives you a unique ID. There's nothing attached to this entity right now. There's nothing. So we need to add stuff. So we can do that by add component data, and we put in which spawner entity that we want to add this stuff, and then we give it a new spawner data. And now we're going to fill in all of this. Count, prefab, random, min, and that thing doesn't seem to be totally fine. Oh, we named it fast random. And then max, oops, ground filter, and then lastly height. And I can see my own error up there. I accidentally took the one with the large M, capital M. So that creates the entity and then adds the component. And now we will trigger this one once. That's it. And we can do this, we can take a look at this quite easily by, first of all, we can just try it out and see what happens. I mean, I'm no magical programmer. Maybe stuff will just burn up. No ground detected, so it might not be the original issue we thought about. A good thing we just commented it out, because maybe we want to return to that. But anyway, we should check out what's happening here. So we have this stuff is properly set up, it will get converted, and we have this ground, my computer is thinking, which have the physics shape, which is part of the ground tag or ground filter, and we've selected the ground in our ground tag. So it all, I don't actually know why this doesn't work, but we'll get to that. We'll figure it out. So let's take a look at this. We also, first we can see, so this spawn system runs. It might not run actually. And I'll explain why that is the case, but it should run. but there's a few things that could be working against us. So here we have our entities, so all our entities and all our systems. And here we should have something called spawn system. There we go. And it doesn't have any spawn data. So we already ran it, obviously, since we went here. Let me just fix one thing. But for some reason we are not finding the ground. So let's attach to Unity with our debugger, and let's see what happens, and see if these start and end values are appropriate and should be working. Cast straight down from this XYZ. This X and Z should be reasonable values, and not much more to look at actually. So yeah. Here we go, and let's put a breakpoint right here. And since this is with structural changes, it will be not bursted, that is. So we can debug this and jump through all of the different lines and see what happens. Slow computer. Now it's coming. Okay, let's see here. So we have, maybe we haven't created it properly yet. It didn't actually stop inside of this. That was weird. Let's see, let's have the breakpoint inside of the for each and see if it stops inside this time. Otherwise, we will make sure that the burst is not running. There we go. So we get 10 of these. The prefab is proper, has a proper value and everything. And then we start to go through, and min and max has minus 100 to 100. That's feels like that's quite a bit far off actually. I don't think I calculate the min max properly. Let's see here. So, maybe we'll have a look at these min max values and see what comes out of them. Maybe the box that we are trying to read from is not really valid right now. Oh, wait a minute, we are in the 0, 0 area, so we should actually get some collisions going on here. So let's put back, look here. So start 35 35 and end at minus 500. Yeah, should be correct. Because this value, let's save this value and see if we can get and just put it out in the world and see where it's at. So let's do it like this, and let's pause it and create a new object and put it at the same point, just to be completely sure that we are not way off somewhere. 500. Yeah, we are just, if we put that at 0, sorry, we are at a very valid point. So we should collide with the ground, and I'm not sure why we don't do it right now. So that's annoying. Let's see if we can find something else. So one of the things I realized that we got the same value twice from random, and that's strange. We'll look into that later. That shouldn't really be a problem right now, actually. So we're not colliding with the ground. Oh, I think I know might be part of the problem. The thing is that we have a system that builds up this collision world, right? And we might want to be sure that we are updating straight after it's built, and not somewhere else in the frame where it might not be properly set up. And that's one of the things with DOTS, is that you need to do the appropriate stuff at the right point. You need to be more deliberate with stuff sometimes. So we use something called before or update before or update after attribute. Update after in this case. So we want to update after physics world. And let's just confirm so I'm not doing something wrong here. So we can take a look at some of our of my other code here. If we take a look at first person movement system and see, because this one also uses collision world right here, and that updates after transformation system group, which is another thing which is after everything with physics. So let's take a look at some. There we go. Here we have one. This is a good example. Update after build physics world, and then we use this physics world for a normal collision check raycast here. So by the same logic, we should update after build physics. And yeah, that should, it might not help, but it should probably be part of the issue. There we go. Oh, now we have some other issue. Ah, you can see we have a box here. So something has spawned, right? Might be all of our 10 boxes spawned at the 0, point. I don't know. I can't see any other boxes around here, so that might be the case. But at least we have a box in the middle. So that's some progress. But we have a native collection thing here going on that we need to address. So this means that we are trying to read something. It says a native collection has been disposed, resulting in a memory leak allocated from. Oh no, that's actually because my Visual Studio is always opening the wrong damn projects when I double click something. So this is because we don't actually dispose of this entity's array afterwards. So after we're done with the whole looping, we should just use dispose and do like this, right? Let's see here. I want to do like this, random, and I'm going to explain why, because I think I know what's going on here. It's tricky with the memory managing, with how DOTS uses memory and makes you use structs everywhere, because it will fool you sometimes. Yeah, now we have our boxes randomly spawned, and I will explain. Yeah, it seems to be working well. So we have a few boxes here. That looks nice. So let me explain what just happened, because this is interesting actually. This is quite nice to see. So first of all, we had our entities, which we didn't dispose of. So just to confirm that, we create them here, and then when we're done with them, we need to let Unity know that we're not going to use them anymore. And Unity will complain about this if you have the leak detection on with full stack trace. If you, it says in parentheses right there, expensive. So make sure you don't use it if you don't need it. And you can also use the only on, and that means they will just note that you have a memory leak somewhere and you need to fix it, but it will not tell you where. So often when you play, you can have it on, and it will be a little bit laggy sometimes because you have it on. And then when you sort of find where you want, then you replicate the issue, which leads to the memory leak, right? And when you find like, oh, this is the thing that triggers it, then you can go stop the game, go back to with false stack trace, and with the bad performance, sort of make your way to the problem area and try it out and see where it actually originates from. So on is a little bit middle ground, so you just know that we got some leak somewhere and we need to turn up the expensive tracking to find it. So we have the expensive tracking on all the time, because when the game is so small as this is, the performance doesn't matter. So we have boxes. And what happened here with the random was that the random object that we used here did not... We picked out a copy of the random object that we tried to use when we did like this. Because in right here means that we just push in stuff. We don't care what happens with it. And that means that this random, the object inside that we pull out, would just be copies of everything. So when we use random right here, and then use the same random right here, it's just a copy of the first one. So they both generate the same random value, because it's just a copy of the first one that came, that we're getting into the system. That's like, I'm 95% sure that's what happened, because as you saw, we got the same x and z value out of the when it looked like this, and then I did something that I declared a local variable, which we have full control over, obviously, because it's our variable that we declared locally in the group, in the function. And then I replaced that, and that local variable is just a copy. So now we can actually, now the next float operation is allowed to progress the random state of the system. So like, yeah, okay, first random value generated, let's take next one. And that means that we get new ones every frame, or every time we call next float. If you're just using random and generate next float on the same random object, which doesn't change, you will obviously get the same value out every single time. Because, yeah, might be over explaining stuff, but that was happened. So now we want to select these guys, and we should actually give them some sort of a component, so they have something which they so they are something, so they are not just cubes. But we can just, so we should make them not cubes visually and in the code in the background, right? So they're not just cubes, and they have some components associated with them. So let's make a new script called unit. Sorry if I'm a little bit rambling. It's hard to keep a straight arrow when you try to explain so many new concepts, and like I don't really know what stuff will confuse who, so I want to cover my bases. Hopefully I don't bore you guys too much with different subtle things. So now we have a unit. Let's see, make sure, yeah, that sounds good, looks good. Now we have a unit, and we should make our convert stuff. Move that over right here. And we have the convert, and then we can do something like this, struct unit data, and we make that an I component data, and the only thing I'm going to do right now is take add component data, entity new, or add component is enough actually, and you're going to see why, like that. So this means that we just add the entity, the unit data to all the entities which own this unit mono behavior. So that means that we can do this. Let's start with the laserbot. So we have a laserbot right here, and let's just give him the unit mono behavior script, and it's nothing more, and then create a prefab from him, an original one. We delete the original like that, and then we go to the spawner, and then we take the laserbot instead of the cube, and we'll press play, and hopefully we'll get a bunch of laser bots on the screen. Whew. Oh, one thing, we're not gonna get a bunch of laser bots because I forgot to convert it. So let's do that. Convert, override, save, and press like that. That should be it. Let's see if we can see any laser bots. Yeah, there we go. There we have two down there. They're standing straight up, and they're waiting for my next command. No, and we can go like this, and we can probably see them as little green dots right here. So I think we should do two things. We should move the camera a little bit closer, maybe I don't know, 50 units up, and then we should spawn a few more. So let's spawn 1,000 and see how many we get, and then we're gonna select them, and that's gonna be interesting. Now we have a bunch, and you can see no performance issue drawing this. Obviously, that's not a big deal for Unity either. For normal Unity to draw all this, but anyway, looks almost like a bunch of ants or like an infection. Very fitting with all the COVID stuff, but anyway. So I want to be able to do the normal stuff where we do like that, right? So let's start off by doing some selection on the screen, and that might be, yeah, that needs some canvases, right? And that's not really dots. It's a little bit annoying to me to be able to need to do something big that is not dots. But we'll see. We're probably gonna be able to do it pretty quickly. Or we can, I'm just thinking about doing this as interesting as possible. Yeah, well, let's do it. Let's just make a selection. It's an RTS, we need selection. So we can do it in normal screen space overlay, right? And we can try to just make some code that draws out this thing. Yeah, let's do that. So we have the canvas, and I want to make it in a sub panel. So let's make another sub stuff here, and let's add a component to it and name that selection system. And this is going to be traditional Unity because the UI is not really converted in any meaningful way yet. There is some stuff you can actually do better if you involve dots, but usually you just do like you normally do. So let's just try to make the hold down click thing work. Private bool dragging, maybe 2 G's, I don't remember. That should be correct. And then let's have if dragging do something, else not. So else, we can do it like this. Also, we can have public key code. Why is it not? I am once again in the wrong project because my stupid computer want to open the wrong project all the time. So let's see here. Key code. No, it's just, never mind. It's just the mouse button 0, obviously. Pressed if input dot mouse button, is it, yeah, mouse button 0. If we press something down, dragging should be equals to true, right? And we should record where we are. So let's do, I'm usually var position, letting the auto generation stuff do a lot of stuff for me, like this. I meant position, mouse position, like that, and then control dot, and bam, we got our proper position. And then let's make this the other way around, inside the dragging, false, and dragging false. We can do basically this. So right here we should be able to do the dragging stuff, right? And we can probably make some sort of a dragging root object here. Let's go to game, and let's make an image that we can manipulate and make it like, you know, the dragging rectangle. That means probably an image, and let's have it so it doesn't have any sprite. So we want to move this around, right? Or make it behave like this one. Let's not bother with the frame just yet. It takes time and it's not really necessary right now. Drag selection square selection square. That should be enough. And so we probably want to make it so the absolute position of the square is the 0, 0 point, the up left point, and that isn't it that by doing something like this? I don't remember. I'm no, maybe not, maybe I'm wrong. Let's see here. So that needs to be, I want that to be 0, 0 in Y. Isn't that something like that? Yes, that's correct. That's at least correct. And then we need to translate over position and width. It should probably be quite fine. Let's see here. That's 0, 0. Yeah, we should, yeah, I think we can handle that. So let's pull in that. Public rect transform square, like that, and then we should calculate the midpoint where we got of the square, because that's where we need to put the square, or the midpoint between our dragging. So that should be variable mid. And we should go from where we started to where we're right now. So that means this way around. And then if we take this value and divide that by 2, we get the midpoint. So let's try that. Square dot local position equals the mid. And let's see what happens. I'm realizing now this might be quite quick and quite easy to do, so that's good. So let's press play. I just put in our square into the variable we just manipulated, and we'll see what happens. So when we do, like, yeah, something is going on at least. We're moving it. We probably, let's see here, let's select this one. Yeah, something is off, obviously. My midpoint seems to be the midpoint here, while it's trying to use this one in the middle. So we need to offset this half width and height. I'm gonna see where that actually originates from, where I'm thinking about this wrong. Let's see here. Well, I think we can just take away half the screen size. That should actually be the thing that we need to do. We'll see. If then that does minus. Let's see here. Let's do a screen size. Screen size. New vector 2, and then use screen with screen height. And we can half screen size. We can do half because that's probably what we need. And let's see what happens if we just do like that. Something is wrong. Oh, that's let's see. We need a 3. Vector 3. It's we're just using vector 3 everywhere, but the Z is just not used anywhere, I believe. It's just a dummy value. For some reason, mouse position is a vector 3, while in reality it should probably be a... Okay, never mind. We need to figure out where we went wrong with that. Half size. Let's see here. Let's think about this for a moment. Oh, sorry. So position right now, it's going to be a specific value, and then this. So let's see here. Let's debug. Let's debug this. I jinxed it when I said it's going to be easier than I thought. I really did jinx it. Oh well, we'll figure it out. I just want to see when we press all the way up to the left, what's the value, and all the way to the right, and a little bit get a few sample points so we know where we're heading. So that's oh right, 0 is down here. So it only moves half the way. That's a little bit strange. Why is... Let me think about this for a minute. So if we take a look at this right here and we just press once, we see that the position is low and the input is obviously it's almost the same position. That means everything should be 0. This should be 0, and then divided by 2 should be just in the middle of those zeros. But for some reason this turns into a big number. Why is it size delta I need to set? I remember that being something that is sometimes used for stuff. Now I'm just throwing stuff at the this UI system is just so goddamn complicated sometimes to know all of the... Alright, that was a size delta obviously. I'm just being... I'm not thinking correctly. I'm just looking a little bit at the different stuff here, but local position should be right. So I don't know really what's going on here. Let's see if we can get this going. Let's find out what the actual value is doing. Because our selection square should be getting x and y value really close to 0. And it's getting a huge value. And I don't really know why. I must have thought about what happens if we put 0.5 in all of this. So we just That might be the issue actually. No, it's not. Um, 0. I wonder if it's just this value which we should use. Let's try this straight up once. This is not going well. And we've been coding for a while, 1.5 hours. My mind might be just running low. Let's see here. Making change, compile and see. Yeah, Brandon, you're absolutely correct. Compile again. And right now I'm just really confused. Like this value, like that, right there. No, let me see it. Let me do like that. So when we have that value is pushed into local position. But the square, this thing here, is at this point. Why is this 12 and 5 translated to this? There's obviously some UI conversion thing going on which I haven't thought about, and I'm really confused right now to why that's happening, because we should just be able to. Okay, I'm gonna just do like this once, put this value straight to something public vector 3 test, and to also confirm even more about Brandon's comments. Like I worked at a quite big company, Stanlock Studios, for those who doesn't know. Well, nobody probably know, but anyway, and like great company and great colleagues, but I don't want to put everybody over the same edge here, or like lump everybody, but a lot of my colleagues, same type of deal. You change a few lines and you try to pick out the pattern that you're missing. And like I worked there for 7 years, so, and a lot of people there had worked on games since 2009 really professionally, and but were very, very, very talented and experienced, and sometimes you saw the most rudimental debugging techniques, and almost like physical rubber ducks every now and then. So it's just programmers, we have our ways, and I think you should just embrace your ways. Now we have a value straight up that we can use. So this is now I'm putting in minus 840 into this square, and the resulting value becomes 60. So obviously I'm not using the right, something is happening behind the scenes with the local position that I'm not thinking about. Let's do like this for let's see here, Unity set UI position. Let's see if there's something I missed. XY through code, blah blah blah, local position, anchored position. Let's try anchor position. Like right now I might be a good idea to read more of what's going on, but like I want to get through this and come to the next thing, because I just want a square to appear when I draw with my mouse over the screen, right? That's the only thing I need. And with goddamn 8 years of professional experience doing so many complicated stuff that I don't even remember, I can't get a damn square to appear on the screen in the right position. But this seems to be actually better, because now if we use this now, so anchored position is probably what we should have used from the beginning. That's probably it, actually. Yeah, so let's just try to swap out this for the anchored position. And this is one of the things that a lot of people, including me, does wrong all the time, is that you like sort of destroy all of your code because you're trying to find some problem, and then when you find it and you try to go back, you're like, oh my god, I've changed so much, there's so much stuff out commented, where do I even begin again? And that pain is real all the time when you really go down deep into a problem. So let's see here. A square. Following my mouse. Maybe I need to flip the Y for the screen. That's possible. Now we're getting somewhere. So we get half the way. So that means that my halving of this is probably just wrong. I'm just being because when you drag a line, maybe it's just the plus. I think this line is wrong. The midpoint, the starting point of the square should not be this. I think it should be some like them plus each other square divided by 2. But let's see here. So now we have something that follows pretty alright. So if we start straight up here and end down here, we get a thing where we, let's see here, we start, it follows me at least, but no! Oh, now I'm getting, okay, hold on for a second. I removed the divided by 2 before because it like followed me halfway all the time. And I thought it should have followed me all the way. But that's not the case, right? Because we want to expand the square itself. That's the point of the drag. So we want it to sort of follow me half speed. Because when you drag out a square, the midpoint of the square, it's only going to follow the cursor like halfway. Because the midpoint of the square is going to be halfway to your cursor. So this is actually correct. And what I should do right now is just make the stuff bigger. That's something I should look up. Unity, UI, size. That's the size delta. That was the size delta. Now we're getting somewhere. Let's try this actually. Square dot size delta equals to and this should probably just be the positive. Right now you probably only can draw the line the square in one direction, so we need to like flip everything if you draw it the other way, but that should be quite easy, just to detect negative values and flip them. There might be some random code I can find out on the internet that does this, but hey, why not write it and see how it looks. This does obviously not work. Oops, my bad. If we do like that, where is the stuff? It's right above us. So we need to minus, we need to take the y dot y minus screen height. Let's see if that helps. Minus. My bad, my keyboard is just messing with me probably. Since I'm from Sweden, I type with a Swedish keyboard. Well, my keyboard is actually American layout because C type languages like C# and most languages is based on a C style with with the brackets and with the parentheses and the semicolon and everything, and it's very obvious that the C-style languages are designed all around an American layout of your keyboard, because you don't need to use as many keys if you're using an American layout. With a Swedish layout, it's a hassle to write code sometimes. There we go. Now we're getting somewhere, I guess. Let's see how that looks. Yeah, we're actually selecting stuff here. But I still think that this thing is wrong. I'm just gonna try to put in position. If it's not the correct one, I think I should back down a few seconds and think about this. Maybe draw it out on in Paint or something to see what's going on. And oh yeah, no, I'm mostly flip stuff right now, so that might be a bigger issue. But let's think about this. So if we were to select the whole screen, that means that let's print this. So this is a good thing. Good input dot get key down, and then K or something. And let's just do square anchored position. Oh, my bad. I copied more. So let's have a look. Oh, that's why. My mind is racing, so I have a hard time speaking at the same time. Let's see here. So I just want to take a look at the anchored position to see what's the deal with it when we are properly sized out to cover the whole screen, and what it looks like, because the anchor position was obviously not what we saw in the XY value in Unity, but I don't know what the anchored position actually is, so I'm going to print it if I press K and see what happens. So selecting square, so if we do this, make it big, and then we press K. So right now the X is like half the screen to the left, right? And Y is probably half the screen up. So it means that the anchor position is upside down and mid-centered. So we need to translate this. I'm actually considering normalizing everything to normalize the values to be easier, so you can like translate all of the data to like 0 to 1 value ranges, 0 to 1. So like all the way left is 0 and all the way right is 1, and then translating it back into whatever this stuff needs, because I'm sure these damn pivot settings are part of the problem right now, and I'm just being lazy. I'm gonna try this as well. Oh, so there we have something different. That might be what I need. So now, okay, so by changing the anchors to 0.5, I just remember that made, so Y is 0 because it's, yeah, it's Y is the bottom one, I think, this one, and X is almost 0 there. Yeah, all right, yeah, now it's 0. So we should have the anchor set to these values to make it scale, to make us able to manipulate the values. So if we start by doing that, we flip this over to 0.5 everywhere, so that all the pivots are 0.5, and then so I'm gonna see what this looks like now. See if it makes a difference. It looks like we're only like offsetted half the screen to both ways. So if we well, X is still weird, really weird, because no, it's not correct. I did not imagine this damn drag square would be the biggest, but it was a long time I did one of these, so I don't remember. And the problem like is most of the time that you're just dealing with some sort of weird reference frame in the UI, right? That's most of the issue in this case. But let's do it in 0 to 1 ranges, and let's try and see if we can make that happen instead. So this is 0 to 1, then halfway there, and halfway there. Yeah. Oh man. Hmm. 0 to 1. So let's do it like this. X is equals to X, and then half it by our screen size, so we can just rip the code out from our player controller, just because I'm lazy. View port, oh, we spelled port wrong, viewport, and put it here. Oh, wait a minute, we just do like this instead. So what's gonna happen here is that we're gonna obviously normalize our values. So both X and Y is gonna be from 0 to 1 instead of the full screen resolution. And then we need to sort of expand them again into normal coordinates before we use them. Let's try if we can make that happen instead. Because that's full width and full height, and this is 0, 0. So 0, 0 should be, like I said, in the middle between them. It should be, I'm almost getting confused again. Let's see here. Let's see. Mid. Let's do like this. Variable mid equals to new vector 3, and then we put in the position X and input mouse position Y, and then let's do this. I just want to save the old code like I said, sometimes you go deeper rabbit hole and then you come up and you realize what your problem was all along. So I just want to make sure I have this code. So if you just Control C, undo everything, copy it, and then redo it. Time travel. There we go. And then let's divide out this stuff instead. But the thing is, I'm wondering if this is really just a plus, since I know I should just go with the new approach that I thought about. But this thing annoys me because it should just be I should just be able to find the midpoint between where I started where I am. And I think I just realized that it just needs to be a plus between there. But I'm still a bit confused if I'm wrong or right here. I'm going to try that, and if it doesn't succeed, we're going to go back. So now it's at 0, 0 all the time instead. Oh, because never mind, because I normalized this. I can't normalize one of them and not the other one. Let me just fix that, like that. So now it's basically like it was before, but we are using plus instead here, and because, yeah, no, it should, I'm probably wrong once again. Well, I mean, maybe we're onto something here. Let's negate that with half of the screen size. We can just take mid x minus equals to width times 2, and then we do the same with y and height, because it looked like it was just halfway off the whole thing. Maybe we need to put a plus there somewhere, and I'm just not thinking straight. Holy damn. Yeah. Yes. How about that? Somewhere I had it probably, but I missed some point. So we still obviously can't draw from anything else but up to from the left, but this should actually be enough for what we're trying to do. So it should be nice. So let's do this. Let's do the selection. Let's do DOTS selection, on-screen selection. This is an interesting thing. And I've prepared a little bit of code for this since before. I'm just going to remove this because we can make it work. So now we have basic drag and drop, right? And the drag is and it's... and we can probably make a start and end position of where we started and where we ended, and then like be able to transfer that into, yeah, we'll get to that. So interesting stuff. Now comes the fun stuff. We need to take all our units and convert them to some sort of screen coordinates, because in normal Unity, right, we have Unity, camera, what do you call it? World. Yeah, CAD foot. Yeah, sorry for the delay on the on me responding to you, but CAD foot. Yeah, trying left to right. Yeah, it's only one way works, but I'm gonna have to think about what's going on, because like I said, it's just so many weird spaces we're working in with the inside of the different panels and stuff, and I want to like let it sink in my head so I can do it faster and not waste so much time on it the next stream. So I can make it work in all different directions next stream. But right now we just want to select, so we will be happy with what we got so far. So normally when we would do some sort of selection, we can do the world to screen point or screen to world point, and then you can like translate all of your different characters into screen space positions and compare them to your dragging stuff, to your dragged square, right? And I mean, it's not nothing wrong with that solution. It's just that if you have 1,000 characters, there's going to be a lot of calls to this world to screen point. And the thing is that, like I explained in the last video, that's basically a random access memory to somewhere where the camera is stored and does these calculations for you. And the calculations is not that tricky. It's well, I mean, no, they are pretty tricky when you first see them, and some things need to be explained about them. But the point is that we can line them up and do all of these calculations parallel for all our units at the same time, more or less, on its own thread even, and like make them appear, put them on all the right spots on the screen, and then do the comparison to our selection square. So we're gonna do that. We're gonna translate all of them to an appropriate on-screen position. That's the next thing. So what camera world to screen point does is basically, I'm gonna start another project, and this was more or less just to confirm stuff before for myself. So when I started this graph drawer, EM drawer, I wonder which one I left it in. Projection test, there we go. So I prepared a little bit about this, and because I know how it works, it's just that, code in actuality can be tricky. So we have a little bit of selection code going on here that I've already written. So we're gonna do basically this, but much faster in Unity DOTS. So I'm not gonna go through this code. I'm gonna write the code in DOTS and go through that as I write it. I'm just gonna have this as a cheat sheet. I don't know if you say that way, but cheat sheets, and we're gonna make it happen. So first of all, we need to find all our units, and we can just start by making a new system here. Selection system base, like we always use, and do like this. Oh, my bad. System base. Why is it not giving me the proper public? What's wrong with me? Public. There we go. Generate constructors, but that's not what. I'm a bit confused now, because this should be just like this one. What's wrong? Oh, I have the same. Oh, selection UI. Let's just rename this stuff so we don't confuse ourselves like that. So we're gonna put the game object that we worked with. It's going to be right beside the system that is going to select stuff for us. And let's move that into the script. The scripts folder. Selection UI, and our selection root still has the selection UI thing going over it. Oh, you can remove test here. So now we can implement. So now we have the update, and now we need to take all our units and put them in screen space position, like I said. So how do we select all our units? Well, it's pretty easily actually. You just do an entities for each, and like lots of you already seen this because I've done this before. Data. that's a lambda expression, so it needs to have its own little thing there. And then run, right? So here we have all our unit data, all our units. And we want to have their position as well. And that's probably going to be something like in local to world, because they might be underneath something else. So we want to use their actual local to world position, or the actual world position. And I call that trans because it's basically transformation from the old Unity with only the global variables, sort of. And we need the camera also, because we need to translate into the camera, so we need to have an access to the camera. And we can do that by hooking it up to a similar thing here, like we have here. So we know our player will have a reference to its camera in one of its components. So if we first of all, in the selection system, make an entities dot for each. Or you know what? We can do this. This is a new thing that I learned. Get singleton. Yes, get singleton. That's right. I did not know about this until a while ago. Var camera data, like that. Singleton must be non-nullable. Okay, so singleton can't be used on a class I component. That's too bad, actually. I did not know that. I can explain what's going on here. So singleton, get singleton is something in system base where you could get, if you know you only have one instance of a specific component, you can get that component. But it only works when it's a struct I component. I did not know that, but so we need to do the thing that I thought about first. Entities for each in camera, like that, and run, and without burst. And let's do like this, camera. Oops, sorry. Equals to, let's rename this to something more appropriate. Player camera dot camera. So what happens here is that we basically find the only one one entity who owns a player camera, and we pick out the camera out of it because we know there's only one who should have one. I'm gonna do like this. I'm very, very red now. Anyway, only one should have the camera, and we need that, and we need to pick out every frame because we might change between different system, and the player camera might change owners or something like that, and it's really very cheap to just look this up every frame, so it's not a big deal. So we find that, and then we need to prepare a matrix which will help us to do this transformation. So full matrix, you can call that, and I'm going to go over here and I'm going to pull this out and go back, and I'm going to explain what's going on. So full view projection matrix, that seems, and let's do null, and we can, if, damn it, camera does not equal to null. Let's do it like that. Let's do it like that. So yeah, let's only do this if we actually have a camera. So matrix math is a whole subject of itself, but let's do it. Let's ease into it a little bit, and I'm not going to try to explain all of matrix multiplication and algebra and everything like that. But what's going to happen here is that we have a matrix which explains how we go from the world position of the camera to the local position. And that's basically like going from 0, 0 and where the camera is in the world, but the reverse. That's basically what that does. And then if we multiply that by the projection matrix, that means that we basically take in the projection, the perspective transformation that you do. So you get, where you have different field of views and stuff like that. That projection, that sort of thing, those settings on how wide you can see everything and stuff like that, that is built into this projection matrix. And by doing, and sort of the course of action here goes from right to left. So first of all, we're taking our object and we're transforming it from world coordinates into the mid, but in relation to the camera. So we're basically taking it to the local space of the camera. And then we also like reverse out the view, the matrix, the projection of the screen. So it will not matter if you have 60 or 90 degrees of field of view or something like that. We sort of make the camera go from a perspective camera to an orthogonal camera. And by doing this matrix, we basically have a matrix now which converts stuff from world position into a camera position, sort of. It's a few things more after this, but this is the start. Unity brought singletons even in dots. Cat foot. Even in dots. Well, the singleton gets a bad rep. I don't really like singletons for much stuff, but it still got a bad rep in some situations, because singleton is just a concept of having one instance of something. That's sort of it, and then having easy access to it sort of is built into the concept. But more or less, it's just you have one of something, and you need to make sure you only have one of them. And there's a ton of situations where there's a component, an I component, dots component, which you just want one version of, or just one instance, and you need that version or that data a lot of times. So it makes sense to make an optimized way of getting that. Like, I only want game mode data, and I only want one of them, and give it to me fast, and that get singleton does. So yeah, I want to say it's a little bit of a thing that you need to go through as a programmer, where you like in the end have like stuff that you don't like, or in the beginning you have stuff that you don't like, and that you're like, this makes no sense and I don't agree with it. Like in JavaScript, for example, a lot of people don't agree with JavaScript as a language and as a whole. But the more you program and try to like open your horizons, the more you realize that it's most about the right tool for the right job. And singleton has a purpose. It's a good tool for some cases. So it's best to be agnostic about which tool is the best, and just use the right tool for the right problem. Hope that gives you some idea into how I think about it, at least. So now we have this projection matrix, matrix which will convert to almost our camera, and we need to, we already have, so we know all the units here, we all the units will get here, and what we need to do is, I can let me just copy this in and go line by line, because it's faster that way. So first of all, we have the global position of the units. So let's swap that out for position like this. So in the old code, this was just a variable I put in. Now it comes straight from this, so it's the global position. And then we have this full view projection, and we have, and most of it works. So let me go through line by line here. So we convert this to a vector 4, and that's because we need a vector 4 to be able to multiply it by a matrix which is 4 by 4, right? So we just put a 1 in there, and that means that we should sort of, it means more or less to take the full matrix transformation and consume it or use it. If you put a 0 there, it would ignore some parts of the matrix transformation. And it's like the difference between a direction and a vector, which has a length also. So it's a little bit like scaled or non-scaled transformations, but it's complicated and it's not really necessary here. All we want to do is take our position and make it into a proper four-dimensional vector, and then we multiply this with the projection matrix, and we get the view position. Like straight up, we get most of the view positions already done. And then this line here, I'm not actually entirely sure what this does, but it basically, I think it more or less takes away some part of the depth in the data, so everything becomes on the same plane. And you will see what I mean with that soon. But that's what I remember it doing. And I'm not really sure about the specifics of just that line. It's one of those things which I've copied in a few times, and I know it does what I wanted to do, but I don't really remember technical mathematical details around it. So we get the viewport position, and then we want to convert that into screen space coordinates. So we half that, and then we take it times this, and this transformation in the end, that's more or less to make it, you know the problem we had with the dragging, and I said maybe I should convert it to 0 to 1 or something like that. That's basically the same thing here. We're trying to convert it into a on-screen position which fits with our resolution. So we won't need that right away, so we might as well like comment that out. But we need to do one more thing here. We need to convert this to the new mathematical library, because vector 4 is not optimized. So if we do float 4 from that, we need mathematics, and we do that. Oh no, that's right. So we just convert everything, and this one is a matrix 4x4, and we need to make that a float 4x4, which is the same thing. It's just in the other math library, sort of. Float 4x4. I think that should, maybe that doesn't convert properly. Yes, it does. So now we have our 4x4, and it's the same thing. It's just a different library representing the same 16 float values. And now we get this problem here, and it's a little bit interesting because so we have a multiplication with a float 4x4, a matrix with a float 4, and this is a completely valid multiplication. That's sort of the point of the matrices, because you can take a matrix and do some transformation to a vector with the same amount of element as the matrix has columns, right? The problem here is that Unity has done it like this. That might enrage people, but I can explain why. Multiply, this whole math library is a huge thing. My computer is loading right now. It's a huge thing, and we can just shuffle. And you have shuffle for every damn type of variable you can imagine. And you have reflect, remap, radian, power of, normalize, all of these. And it's because this math library is implemented in such a way that it will utilize the burst compiler in full. So imagine we having like 16 different units that all needs to do this. What the burst compiler together with the math library will do is that it will line all of those 16 units up in memory, and it will sort of line all the different transformations. All these operations will line them up in memory with parallel execution, and bam, all of them will crunch through the system at once. And that's a huge part of burst and dots in general, to be able to vectorize the operations. That's the general name, vectorize. You will sometimes hear the concept of SIMD, singular instruction, multiple data, and that's the same thing. You take a bunch of parallel streams of data, or parallel stuff that's supposed to where everything is supposed to have the same operations applied to them, and you make them all do the same thing at the same time, and it saves a huge amount of CPU cycles. So that's what's going on. That's why it looks like this, why we can't just have a normal multiplication symbol, right? And then we have this, which tries to convert from float to, and I think this is more or less because we don't need to convert it actually. It's not a big deal. Well, by the time we get to viewport point, it will be only X and Y that we are interested in, because that will be 0, 0 to 1, 1 on our screen. So we will take the position, the in-world position of a unit, and it will find the exact screen on the exact position on the screen with this thing. So this is what's going on behind world point to screen position. That's the same thing. So we can print this out and see what happens. Actually, without burst, so it doesn't give us a lot of Unity engine debug.log, and this is now the rubber meets the road. Let's see what happens. Let's see if first of all, if I made any mistakes. Probably I've had. I'm not a saint in this, but let's see if it makes sense. And now we're just going to generate one unit, and we're going to move around the screen, and we're going to see if this value changes, because if we move around the screen, the coordinates of the unit, its on screen position should change as the screen change, obviously. So let's try that. We can disable this for now. Oh, and we should only spawn one unit, my bad. Come on. We got a few of them out, that's for sure. So spawn only one, and let's make the spawn area like 20 times 20, so we get it a lot closer to us. So now we get our single robot just beside us. And we will see the screen cord print out the appropriate value. So 0, 0. So since my resolution might be crap, I'm gonna move way closer to the action, and but it worked. I saw it work, so don't worry. I'm gonna show you so you can see it properly. So there we have him, right? That's our green little dude. And you can see at the bottom, if you look up, it's a bit tricky to debug this when you move your camera all the time. So to the left in our console, it says 0, 1, 0, 5. So that means that we are 0.1 unit in X. So imagine if 0, 0 is here, right in the middle, then this little guy's X value is 0.1 unit to the right, and then 0.5 unit up, because this is 0, 0. This right here is -1, -1, and this is 1, 1. and there we are. So if we move all the way here, very, very far there, you can see that the screen coords says that the X value is 1. So he's all the way to the right. So we just converted his actual in-game position to a position which represents where he's on the screen. And let's actually see if we can display that in a way to make it even more obvious to what I've done, because it might not be super obvious if you haven't seen one of these transformations before. So let's see here. I'm gonna do like this, make a UI image, and then make it a little bit smaller, 1010. And let's see here if we can. Now we're back into the same problem as we were before, apparently. We're probably gonna find it, find the solution pretty fast. Let's see here. We can actually just, in the start of this function, just create a dummy. No, we can't actually. Never mind. It's hard. It's better to, let's do it like this. So let's make it rect transform dot test point, like that. And then let's, no, that's not. We move over to the, this is just for debug purposes, so don't pay too much attention to the actual like details here. So we need something that has, you know, the inspector view where we can find where we can pull in our image. So we have the spawner here, and just so we get a handle onto our image, which is in the middle of the screen here, and we can move it around, because right here in our selection system we don't really have access to the UI right now, but we can just pull in a random object and then a handle to it, so we can move it around and see what we are doing. And the way to set that then is to do like this. Test manager.world.get or create system, and then we get our selection system. So that will get this system that we are working right now, and if it doesn't exist, it will create one for us. And then we can do like this, a new value here called test point, and we just copy over our test point that we have set in the inspector and make sure that the system has a reference to it. That's it. So just to have access to our test point. And let's try this now. Position local position. I'm gonna take a look at my other just to see, so I'm not local position exactly, that's correct, and that might be correct. So I'm gonna explain more when I see it, but what I'm trying to do now is just take this little white square and line it up with the guy on the screen. Might be obvious, but yeah, there we go. So let's make that some other color so you can see it, and make it a little bit bigger. Good thing that I prepared that code. So now we have our dot on our screen, and there's much stuff behind this which is interesting to think about. So there you have the red image, the red square, and we can actually do this. You probably see him, but I just want to make sure that everybody sees him. The green square, and he follows, that follows perfectly, right? Might be one frame off, but that's ordering ordering problem, not just make sure that we do it in the right order, and we probably eliminate that off by one frame. But that works. So that means that we have translated our position into the screen position just straight up, and it works. And that's pretty exciting, because what we now can do, and I want to just explain the powerful things we are looking at here. So with this screen coordinates position, we have something that we can use in aggregate. So we can produce a lot of them, and we can make quick selection decisions on a lot of already pre-calculated on-screen positions. Instead of, calling this 1,000 times to find all of our characters and where they are, we sort of crunch this in a much faster way. And if I do like this, so now we're getting into the fun stuff here. Schedule parallel. So what does this mean? This will mean that if we have 1,000 of these, Unity will spin up maybe, I would guess 8, maybe 6, maybe 12, something like that, threads, individual threads on my computer. I have an Ryzen 5 3600, so it's not a slow computer, but it's not the latest on the market. It will spin up a bunch of threads and put them out on different cores, and it will make all of these calculations in parallel on all of the different units at the same time, and it will be blazing fast because it's burst also. So imagine you have 1,000 character, 10,000 units. You split them up on eight different cores maybe. First of all, you reduce all of the overload heaviness by 8, so you get this many per core. And then imagine you have a core which have a fully functional set of simmed instructions, the thing I talked about before, being able to actually calculate a lot of the same type of calculation at the same time. And I should not say exactly because I don't remember, but I think simmed in the latest creations can do somewhere around like 256, 512 parallel multiplications. So imagine doing this stuff 512 of them at a time. That's 112x the speed. So if we just being conservative here and say like, oh yeah, it's going to be able to vectorize it and pull it through 16 numbers at a time, then we reduce our load from 10,000 to 78. That's basically the different scales we're working at here. Because we're bursting it, we're doing all of it at the same time, and we're doing it on all our cores at the same time. And that's the true power of DOTS. And this schedule parallel, that's more or less it. That's how you do this. But you need to be aware of how you use it, because a lot of different data behaves in a very specific way when you do it schedule parallel and with burst. Some stuff are just plain impossible to do, and Unity will have a lot of safeguards so you don't do the stuff that is bad. And a lot of safeguards are sort of arbitrary at the first glance, and then when you look into it, and they are just trying to protect you from yourself basically, because multi-threaded programming is hard, but with DOTS it's a lot easier. So what we can do here is, first of all, we need to find out how many units we have, because we need to pre-allocate a long array where we can save all our finished work, because these lines are going to be run by everybody at the same time, so they need everybody to be aware of where they're supposed to put their results. That's like a key thing to like signal out of this multi-threaded, highly optimized little box that we are currently inside. So let's create an entity query. Just shoot me questions if what I just told you were complete Chinese or whatever. It took me a long time to get familiar with this, and I have an education in computer science which lets me sort of reason about this stuff without dots. So I've had classes about multi-threaded problems, and it's like dots make it so much easier. But it takes a long time to get. So enough about that. Let's create stuff here. Private entity query. We can name this unit query. And let's get entity query type of, and do one of these. And let's do like this. Variable count equals to get count there. So what I'm just now doing is I'm creating one of these entity queries which I explained earlier, where you can specify exactly what type of entity you want to get. So now we're just getting every entity which owns a unit data. And we're asking the query of how many are there of this type, of this combination of types, maybe you should say. So right now we only have one, we only spawn one bot, right? But what we can do is like, we can have screen positions. Let's make a struct, and you will see what I'm going with this in just like a minute. Entity with screen point public entity public float to screen point new native array count So a lot of stuff happened. We created not a lot of stuff, but I wrote a bunch of stuff. First of all, we create a struct, and it's just something so we don't have to have multiple arrays, so we can package stuff together. And then we create an array which has the exact number of units, so we can fill in the entity and its screen position with every one of the units. And what we do next is that we should put this in, and let me just start by just writing the basic code so we are on the same page here. And this is nothing fancy. Entity and there we go. So first of all, entity right there is, if we just add the parameter entity to the beginning of the for each, we will just get the accompanying entity that owns these components, right? And we had no use for it before, so I didn't even put it into the parameter list. But now we need it, so I put it in, and then we have the screen coordinates or screen point. I use point for some reason. I don't know. Maybe I should rename it to coordinates, but screw it. You know what I mean. And then we have the 0 here, and that's wrong right now, but because I wanted to wait with this. So in this thing, we have one more different type of input. We have an integer called entity in query index. I'm just gonna confirm that I'm not talking out of my, you know what I mean. So it actually is this, just because, it's the other way around probably. It's let me see, entity in it's the index of the entity inside of the specific query. I'm just looking for the actual name of it, because it's the other way around. I think it's entity. It's index in entity query. Something is I must have misspelled something. Let's see here if I can. There we go. Okay, now I got it. So this is the name of it. Entity. Oh, I had an I. I had one more I in the query. So entity in query index. That means that every single entity that rolls in this loop, that will execute in this loop, all of them will have one unique index, and it's only related to inside of this loop. Entities does not really have a global index that relative to anything else. It's just a unique identifier, but it's not ordered in any way. This will let it have an ordered index for a brief moment while we execute this, so we can sort of know where we are in the execution. And that's the stuff we put here, because then it means that if we have 10 units, we will create 10 blank spots in this array, and then we will execute these 10 units, and for every unit we go through, they will have their appropriate index, 0 to 9. And that's how you sort of index. Because remember, we can't do a plus here. That's not possible, because we're on all different cores and everything, and it will not. All the different cores will execute in various speeds and in various order and everything, and it will be more or less a mess if you look at the whole picture. But if you just look into this single function, that will be a contained structural mess, or sort of order in the mess. So this way we find where we are in the particular loop, and like I said, this value might be split sort of, so you have half the entities executed on one core and half executed on another core, and then this value will go from maybe 0 to 5 on one core and then 6 to 9 on another core. So that's the way it splits it up. Yeah, that was a lot of stuff. So now we can produce that. So we should be able to confirm this. So what I'm doing right now, I'm calling a function, which is really only for debugging purposes right here, and I'm saying to Unity dot system that complete all of the different parallel work stuff you have going on, and that entails this one basically only right now. And then we can take a look at this. So then we can do Unity and let's do for loop dot length and do Unity engine dot debug. Oh, we have actually the namespace already here. Log. We can just write it out. So let's do one of these at least. So now we will see the its index and the screen. Let me go back here. We will see the index of the object in the array and its screen value, right? Actually, we won't, because we need this particular screen pointer right there, right? Because we have both of these in the array. So let's spawn 2 of them, so we can see some difference at least. 2 counts of them, and I'm gonna pause so we can like press once. 1 frame forward so we can see it more clearly, because now it's just going to spit out a shitload of stuff. I'm getting some yeah, that's not a biggie. we actually get 4 of these. That's interesting. So for some reason we're getting 4. Maybe there's something I did, or maybe we have some units which I didn't realize we had. Because like I said, this is going to query for everything that owns the type query or owns the component query. So if we take a look here, we can filter. When you press that, we get a filter, and then we can say unit data. And we have actually 4. Did I press in 4? Am I just really behind? No, 2. We're probably making something that makes the randomizer or the spawner run twice for some reason. I'm not sure why, but it doesn't really matter. And right now we have a collection leak, and that means straight up just that, sorry, wrong project, that this native array that we are creating to save our screen positions, we never dispose of it. That's it. So we just do dispose. And let's look at this again. We can take one frame at a time. Bam, and we have a bunch of different. And if we go up here, we are not longer setting the position of this guy, so it's not showing up properly. But yeah, you can see we have generated all of our appropriate screen positions. So now comes another sort of important core part of DOTS here, because right now we are actually completing our dependency tree, our job dependency tree, which means that we're taking everything that depends on everything else that we've set up in jobs to, like, oh, this is a whole like net of different data flowing in and out of different jobs, to be able to do it as fast as possible on as many cores as possible, multi-threaded. And we're just saying to everything, just be done with it. I want to read the resulting data. And this is like, you need to do that as few times as possible. You need to set up your whole dependency tree and like say like, oh, this is everything we need to do, and then go. And then you need to like wait out everything and then pick out the data and draw it. That's sort of the whole idea here of like parallelizing. I can't even pronounce it. Anyway, it doesn't matter. Putting everything up for calculation and then crunching it, but letting it crunch in, and then like 16 milliseconds. If you're hitting 60 FPS, you need to do everything within 16 milliseconds, and then before 16 milliseconds, like time's up. Let's see what the result is, and let's put it on the screen. So that's more or less how this job dependency system works. And right now we're just forcing everything to be done with it way before we are trying to present it on the screen, and that's unnecessary. There's no reason for us to have this value here, because we can do that later in the frame. So for example, we can let this generate all our screen positions while we do all our other logic with our game, right? That's like core multi-threaded behavior. It's tricky to do, but the concept should be quite easy to understand with this. We'll let this crunch in the background while we just continue on with the game frame and do whatever we need to make the game happen, and then later we check out the results, right? So Unity has a way of doing it, which I think they call it barriers, but I think that's a little bit of an unofficial name. I used to call them sync points. Maybe I've mixed something up here. If somebody has anything to say about that, please do. But from what I understand, barriers and sync points are the points where this thing will be executed, and you will wait in all of the different threads and make sure everything is done, and then get on with the frame. So they have 3 different sync points in the game, or 2 maybe it is. Depends on how you see it. So you have, you start a game, and then you initialize the whole game, or initialize the game frame, I mean. Initialize the game frame, so we're talking about one frame here. You initialize the game frame, and then you have a sync point, which means that everything that is multi-threaded and parallelized and everything like that needs to be done when the syncing, when the initialization is done. And I can show you this. I realize now I can show you a little bit of how this looks, because the entity debugger has a good view of this, and it's easy to see what I mean if you take a look at this. Entity debugger. So let's pause this and pull this up. Here you can see. So we have 3 different subcategories. Maybe let me see here if I can enlarge this. There we go. Ha. So here we have just ignore the top one. First we have the initialization, and that has something called the initialization system group. And right here we do a bunch of stuff. We convert, we update world time, we do a bunch of stuff that we need to do each frame, but in the beginning of the frame. And then we say to Unity or to the DOTS system, complete everything. Be done with everything so I can look at the results. And then after that is done, we do the simulation system group. And here you have physics, build physics world, display joint system. I don't know really exactly what that is, but step physics, we all know what that is. We step the physics world 1 step forward in time. And then we have the transformation system. So that handles all of our local to world transformations and parenting and everything like that. And we do all of this. And then we come to end simulation entity command. It's a long name, but that's the end of the simulation frame. And we say to Unity, to the DOTS system once more, please be done with everything so I can look at the result. And then everything is done. And then we go into the presentation system group. And here we just take the result and push it out to the screen, more or less. That's it. That's the frame of the Unity DOTS system. And so right now there is built in sort of three different sync points, each one between these, where everything will sort of stop and wait in all the cores and make sure everything is done, and then move on with the next part of the frame. And when I do this, I introduce one more sync point, and that's just, we can use their existing sync point to make this happen. So let's push this system-based object, our system, to execute in the initialization system group, so it then can. Oh, I realized I didn't zoom out. I hope you saw that one. There we go. This one introduces a new sync point. And we should not introduce extra sync points if we already have 3 of them. It was really tricky to look at to do this zoomed in. I'm gonna try to make that better in the next time, to have some automatic zooming. So we're gonna prepare our screen positions in initialization system group, and then we're gonna execute the selection based on those positions in the simulation system group. So how would that look? Let me zoom out this stuff. Let's do like this. I'm a newbie with the OBS, I can tell you that. There we go. So let's erase these 2. We don't need the resulting screen positions yet. And let's put something called update in group, type of initialization system group. So that means that the selection system group will live in that first section of the frame. And then let's do something else, which is a mouthful. And initialization and initialization entity command buffer system. So this is sort of the end system of the initialization phase. So you have the initialization phase, and then this system will execute right at the end of that phase. So DOTS people usually call this ECB system, stands for Entity Component Buffer, but that's for another day. But let's call it that. It's just a name right now. And then let's do the world, because this is a system just like any other. So you get it by getting or creating the system at the start, and then you have a reference to it. And then we do something called add job handle for producer, and we pull in dependencies. And this is a little bit tricky. We will try and see if it works without this. This might be a little bit legacy, but the whole concept that I had explained is very important and it still holds. This is just that I don't remember if you need this still, but this is basically so that that endpoint of the initialization phase, so that point knows that this needs to be done, more or less. So don't pay too much attention. The overall arching idea and concepts are the most important. Monsieur Tilla, I can still pronounce your name. I'm sorry. Yeah, be going on for a while. I'm gonna end like in 5-10 minutes. I'm gonna just finish this structure, and then I'm gonna rest my throat. So we need another system executing in the next phase, so we can pick up the pieces or pick up the result of this screen position. So let's start something called class. We can name this thing and rename this prep, data prep, because we're basically just prepping the data, the screen positions. And then system base, and let's implement this, and let's do this. And then instead of update in the group of initialization group, we do simulation system group. And public void set buffer. You will see what this is in just a second. So we need this to be public outside. You know what? We're gonna move that over so we don't need that long of a namespace, and we're gonna do like this instead, because we're only using it in 2 places right now. There we go. And then we're gonna create an instance of this array that we are working with, the list of our on screen objects. We can name them on screen data buffer, and let's do it like this, buffer. And then in the end we need to take this system and let it know about this system, so we can push over, make it like receive all our data, sort of like, oh, here you are, here's the buffer that you wanted. That's more or less what we're gonna do. So let's create a private variable, which is the selection system, and we're just gonna get that like a normal system, like this. So we get a reference to that system, like that, right? Just get it or create it if we don't have it. And then right after we created this array, we're gonna set the buffer over. So think about that for a moment. This buffer, this native array is Unity's own system, right? But this is a handle that we can move around. It's more or less like a reference, like a normal class, but it's based on Unity's own memory management, which is much faster for our purposes than C#'s own, right? So we basically create this, and this variable itself, it's more or less just an index, like I said, a reference. And we put it in to this, so we can write to it, right? But we also send it to this system, and this is a handle to the same array. It points to the same memory address. And now in update we can use this. So we can do for length. This is the same array that we allocated up there. Debug.log. And this is the last thing I'm going to do, and I'm going to explain it properly, and then you're going to have to marinate on that for a while, I think. So now we're going to print out, and we're also going to dispose of this. That should be working actually. So what's happening here is that we're setting up this multi-threaded story, which is going to generate all of our positions. And we are telling our own system, like, we're going to generate a bunch of valid data for you to use in this buffer, in this native array called screen positions. So take care of that array, and then in the next phase of the update order, so the first generation of the data is in initialization system group, the first stage of the frame. We start generating everything, and then by the time we get to the simulation phase of this of the frame, all these paralleled work tasks have been will have been completed, and this array which we have access to now will be filled for us with all the values we want. So that's DOTS for you. that's a core part of DOTS. I have something wrong here. Let me. I swapped names, so that's the only reason. So yeah. There we go. So if we do like this, we still are not putting this red dot on top of anything because we don't use it anymore. But if I play one frame forward, what's happening here right now is that this data is being generated in parallel with this job, and the result is being pushed out into this array, and everything is finished up by the time we get to simulation system group, and this for loop then picks up where the other stuff left off and displays the data. So now we actually, this is straight up proper multi-threaded gameplay code, more or less. Not necessarily gameplay code, but the selection system for RTS, properly multi-threaded to be able to handle thousands of simultaneous entities. Because, yeah, it's so pure type of code. It's gonna execute super fast, like extremely fast. And that's it. That's for now. That's how far I'm gonna go today. I'm gonna try to prepare a little bit better next time, because the selection thing, the selection square was annoying to be able to need to handle on screen or need to spend that much time with. So I'm gonna prepare a little bit better next time, so you don't have to look through my debugging as much. But it's also part of the thing, and this might be a good record for somebody working and to look at, this is how it can be done from somebody who's done it a while. So I like to present the whole problem, not only the good stuff where it's all functioning. Maybe I'm wrong with that, but hey, That's my thought about it. So let's do one more quick overview of this. We find our single player. We find the player's player camera, and we get that out. And since this is a run and without burst, this will just execute straight away, and we will get our camera. And then we count our owl units, find out how many we have, and create an array with as many spots as we have units to prepare for the data. So we have a bunch of empty data to fill, and then we send off that reference to the next stage in the update frame. So the next stage can sort of consume the data. But so far, the next stage will not matter. Nothing had happened there yet. And then we prepare our matrix, which will convert stuff from world position to screen position. And then we go in and we loop through all our units. And we take their position, we push them over to a screen. So their in world position becomes a screen position. We do some converting with it, and then we put it in its appropriate spot in the big array we created before. So this will be executed by a lot of threads really fast, and we just let this go. We just say schedule parallel, do it as fast as you can whenever you can. And this won't execute for a while. When we have set this up, this frame, this initialization system will work with the rest of your systems in that initialization phase. It will continue with that phase, and it will just make sure that your cores on your computer start up and start doing this work for you in the background. And then the rest of the initialization frame would crunch on and do everything that you want it to do. And then we go into the simulation phase. Everything will complete properly. This whole parallelization will be completed and done. And then you have your reference to the buffer you created and you filled. And you can use it. Might be over-explaining, but better that than I just gloss over it very quickly. So, please leave a comment if there's anything I should do differently. And that's it. Next time we're gonna make so we actually select stuff on screen, so we see what we select. Thanks for watching, and yeah, see you next time. Bye.